So, hi everyone. So here we are again. Now we are going to solve for this Fourier series, and they said, okay, find the Fourier series of fx equal to x squared in the interval of 0 to 2 pi, and hence deduce that pi square divided by 12 is equal to 1 upon 1 square minus 1 upon 2 to the power 2 plus 1 upon 3 to the power 2 and minus 1. Okay, now let's go to what is really important. See here, okay, this is the enunciated, this is what they're asking. And see, first we have to write what is the formula of this Fourier series. Okay, this is the formula. But now we need only to find what is a0, what is an, and what is bn. Okay, and also we have to find what is L. L here is the period of this function. So now, okay, let us just start working on this. First, what is L? That's the point. So here, comparing these limits, okay, we can just start this one, a0. Let us start by finding a0. What is a0? a0, first here we will compare this limit, 0 to 2 pi. So 0 to 2 pi, let me just compare this limit, 0 to 2 pi. This is the limit. So these limits here are similar to this one, to the Dirichlet limit, if I can say this one, c plus 2l. If you just compare this expression with this and this with this, you will understand that here, okay, here c is 0 and 0 plus 2l is equal to 2 pi. So from here you will understand that L will be equal to what? L is the period, will be equal to pi. Okay, this is just to okay, 0 to 2 pi. So 0 is c, okay, for Dirichlet limit, 0 to c, and here 2 pi is equal to c plus 2l. So this is what you got here, 0 plus 2l, then L, that is the L that is your period, will be pi. Okay, now let's go. Okay, so we'll be just substitute the limits here. I know that it will be 1 upon L, okay, integration. It will be c plus 2l upon c, okay, and then this will be fx of dx, and an will be 1 upon L, okay, and c plus 2l, then c fx time cosinus of what? Cosinus of n pi x upon L dx. Okay, so bn here will be 1 upon L again, then here we have c plus 2l. I'm just writing the formulas, okay, then we will just start solving this one, n pi x by L and dy. Sorry, dx, not dy. Okay, dx. So now that we know what is L, okay, it is directly, this is 0, so it will be 1, okay, this is 0, so this will be 1 by pi, okay, and here it will be 2 pi and 0. So here you will get what? It will be fx. Fx is x squared dx. I'm just writing, I'm not solving, okay, I'm just writing down, substituting this value. So 1 upon pi here also, integration of 2 pi, 0 from 2 pi, then x squared, then cos of d. If I put pi here, I will remain only pi by pi 0. Pi by pi will be 1, will be only nx, okay, dx. And the same here, 1 upon pi, integration from 2 pi to 0, and this will be x squared, then sinus, the same, pi by pi 0, pi by pi 1, nx only. It will remain only nx dx. So, okay, we have just to find what is this integration, okay, the value of this guy, and put it here. Okay, the same, the value of an, and put here the value of bn and put here. Now we know what is L, okay, we just compare, then you find this one, but this limit. Okay, now just look very well at this point. We will start computerizing this one. We'll start to solving for this, then for this and this. Okay, let's go. Let's go. Okay. See? Okay. Yeah. Now let's move. Let's go. Okay. Now let's go. So what do we have to do first? Okay, we have to understand. First, a0. It will be equal to 1 by pi integration between 2 pi 0 to 2 pi. This is x squared. Okay, dx. Even babies can do this integration. Huh? So 1 by pi, so it will be x to the power 3 by 3. So it is in between 2 and 0. Just substitute there and you'll find this one. Okay, just substitute, you will get this one. This one will be for this one, this will be what will be 2 pi, and when you substitute 0, it will be 0 directly. So just substitute this one, 1 upon pi, and this guy will be 2 pi, okay, cube upon 3. Okay, yeah, this will be the result. So here you'll get 8 pi cube upon 3 pi. So this will be 8 by 3 pi square. Okay, this one. Where is my red? Okay, here you have my red. Okay, 10 count. Okay, then you get this one square. Now we know what is a0. Okay, okay, so a0 by 2, divide here by 2 also, a by 3 by 2 pi square. This one will be 8 by, okay, 8 by 6. You are just by 6 pi square. This is the same as 4 by 3 pi square. Okay, now we know, okay, a0 by 2, it is 4 pi square by 3. Now, okay, it's nice. Done, Veloso. Done, people. Okay. Now, what is an? This is 1. 2. What is an? Just go to the formula. An is what? 1 upon pi, integration from pi to pi to 0. And this will be x squared. Okay, just remember, you can pause the video and see. Okay. Integration of this guy, so it will be cos of an x dx. This integration, okay, you can just do double or triple integration by part. But see, there is a very easy method that I usually used in Angola. I don't know if it is valid here, but this is already done, solved. Okay, this can solve any problem like this one. But now we have a polynomial and we have cosinus or sinus. So we have just to substitute this one. Divide this polynomial, this one, x squared. Okay, x squared. Then we have here the integration of this cosine nx dx. Okay. Now what we will do? We will just first derive this one till you get 0 in the derivation. Okay. Okay. First derivation it is 1. Second, okay, second derive this one. This will be only 2. Then if I derive it will be 0, so I stop. Okay, now I integrate the same way. Now I integrate this one, cos nx integration of cos nx, it will be sinus nx upon n. Nice. Now I integrate again, sinus integration, it will be minus cos nx. Now here, if it is n, it will be n squared. Okay, just integrate again. You integrate this one, now integrated this one, and integrate. Now I will integrate it again. Okay, I have to integrate how many times? Well, also 1, 2, 3. So I have to integrate 1, 2, 3 also. Okay, so integrate again this cosinus. If you integrate cosinus, it will be sinus. Okay, sinus will be sinus of nx, and here n cube. The sign will be the same. This one. Now, what is the magic? The magic is that if you just multiply this and this, this and this, and this and this will be the result of this integration here. Okay, so plus, minus, and here plus. Just multiply these guys, multiply and multiply. So it means that this integration will be equal to 1 upon pi, okay, and here 2 pi to 0, okay. This integration will be this one, just this and this. It will be x squared, and here sinus sin nx, okay, upon, sorry, there will be no more integration. I have already integrated, okay, I have already integrated, okay, by n. Then minus and minus will be plus. Then I will get 2x and this guy, 2x and cos of nx upon n squared. Then I will get this and this. It will be minus 2 sinus, okay, minus 2 sinus nx all upon n cube, okay. It is between 2 pi and 0. Okay, hope you can understand this one. You see how we did this one. Okay, this is the integration in this way. So after doing this one, what you have to do, just 1 upon pi, okay, 1 upon pi, and just put here for 2 pi, 2 pi, and 2 pi. Okay, here you have to understand very well about this sinus of 2 pi. So x is equal to 2 pi, so you have 4 pi square, then you have sinus of 2 pi, okay, 2 pi n upon n, plus 2 times 2 pi will be 4. Where you find x, put 2 pi, okay, 4 pi, and here cos of 2 pi n, okay. So here I will not get too much space, yeah, no more space here, but I will try to do my best. 2 sinus 2 pi n, okay, yeah, just try to understand. Here it is 2 pi n, okay, 2 pi n, n cube, okay. This expression here minus, okay, minus, okay, then I will substitute for 0, 0, 0, 0. See, if I put here 0, it will be 0, okay, 0, okay, second 0. If I put here 0, it will be plus 0 again, and if I put here 0, it will be also 0, also 0, minus 2, 0. Why? Because sinus of 0 is 0, so 0, 0. So I will remain only with this part here, this part here, this one. Now let us analyze. Sinus, see here, sinus here, this part of 2 pi n, okay, this is also 0. Whatever n that we put here, n equal to 1, 2, 3, 4, 5, 6, 7, it will be always 0. So this expression is also 0. Now this part here, sinus of 2 pi n, this will be equal to 1, 2 pi n, okay. So if I put here, suppose cosinus of 2 pi n, this is equal to 1, always 1, okay. Put here 1, 2 pi, 1. Put here 3, 6 pi. This will be always a even function, so it will be always 1. So it will be 1 upon pi, okay, 1 upon pi, and here 4 pi, 4 pi square. If you do the same, oh, see here, okay, this is also 0, 0, because sine of 2 pi n, 0 again. So what we will remain with? Only with this cosinus, and here it is 1. So it is 1 like this one, if you can see, okay. And this is sine of 2 pi n, this is 0, 0. So because n is a integer number, okay, so if I put in an integer number, it will be 0 directly. So it will be only 2 pi, 4 pi times 1 divided by n square. This will be this. So it means that this guy will be taken out by this guy. So an will be 4 by n square. Okay, okay, done. It's nice. Now we are going to solve for Bn. Okay, now we know what is An. Now we have to solve for Bn. Nice. Okay. Okay. So I was saying. Okay. Now we finished. This is An. So we just put here in bracket. This is what we are doing. Okay. We are looking for An. See. Here, see here, we are looking for A0. We found A0. We found An. Now we are looking for Bn. Okay. Okay. What will be our Bn? Let me put here this one. So for Bn, see, for Bn is equal to 1 by pi. Again, we have the formula. Okay. If you forgot, just do not forget. Stay with me. Okay. Stay with me. It's okay. It's this one. This is Bn. Okay. Okay. This will be 1 by pi, and here 2 pi, and x square 0, and here sinus of nx, and here dx. So we can use also the same method that we used last time. So here we have px. Okay, it is x square, and here we have the integration of sinus nx dx. So here we find derivative for this guy and derivative for this guy. T will get here a constant 2. Now we integrate this sinus. Sinus integration, it is minus cosinus nx upon n. Then integration of cosinus, it is positive sinus. So it is sinus nx upon n square. Positive sinus, but this minus will also be here. So positive, negative, will be negative. Nicely. Then integrate nicely this again. So integration of sinus, it is negative cosinus. So negative and negative will be positive. So it will be cos nx, okay, upon n cube. So now we do our nice playing. Okay, this and this, this and this, and this guy with this guy. Okay, we just multiply them, multiply them, multiply them. This is positive, this is negative, and this is positive. Okay, so in this way, when we multiply this, you will get the solution for this integration. 1 by pi. Okay, this time this is minus x square, and here it is cos, okay, cos nx upon n. Then we go again, minus and minus will be plus, so 2x and this guy. Okay, this will be plus 2x and sinus of nx, okay, upon n square. Then here plus 2, okay, 2 cosinus of nx upon n cube. Okay, this is from 2 pi, okay, from 2 pi, from 0 to 2 pi. Okay, see here, are we together? Yes, we are together. Now, okay, just find this guy, but you will get this one. Find 2 pi, for 2 pi here, put 2 pi here, okay, you will have 2 pi here, 2 pi n, and here 2 pi. This will be minus 4 pi square, and here it is, we know cos of 2 pi n upon n, plus here substitute by 2 pi, it will be 4 pi, and here you get sinus of 2 pi n, okay, upon n square, plus 2 cos of 2 pi n. This is by n cube. Okay, it is in between 2 pi minus 1. Now let us do minus, okay, minus the second part, okay, when this is 0. Put here x0 will be 0, x0, 0, x0 it will be 1. So you will get only this one. So if you put x0 here, you will get this one only. So what you will get? This one only. Okay, yeah, what you will get here, you will get, just put here 0 0 0 0, and here what you will get 2 upon n cube. This is the only thing that you are going to get here, 2 upon n cube. So this will be 2 upon n cube. Okay, now we know that here it will be 0. Cosinus 2 pi n will be 0 always. Here it will be 1, and here it will be 1. Now just add all it. Okay, it will be minus 4 pi square upon, okay, n, because this is 1, then plus 2 by n cube minus 2 by n cube. So this and this will be cancelled out. So minus 4 pi square upon n is bn. This is bn. Okay, this is bn. Sorry. This is bn. Just computerize this one. This is bn. Okay, now that we know bn, un, and everything, we have just to substitute. Okay, let's go. Okay, we'll just substitute. So what is fx? Fx, okay, fx is a0 by 2 plus an, okay, from 1 to cos of n pi x upon l plus bn, and this guy, n goes to 1, then here sinus of n pi x by l. Okay, so what we have to do, let us write fx will be a0. What is a0? Now we have to go back and check our paper. 4 by 3 pi square. So this will be 4 by 3 pi square. Okay, plus what is an? We have to check our paper. If you check it, you will see 4n square. 4 by n square. 4, okay, 4 by n square. 4 by n square, okay, 4 by n square, and this guy will be here, n, okay, and here, what is l? L is pi, we have found, so it will be nx only, plus, then we have to find what is bn. Bn is minus 4 pi, okay, minus 4 pi square by n. Okay, let me just, it will be minus 4 pi square by n, okay, by n, and this guy, this will be 1, and here it is cos of nx. Sorry, not cos, it will be sinus of nx. This result is very long, so you have just to be quick. I'm just taking too much time because I'm explaining it slowly, okay, slowly, so that you can just understand. Okay, okay, now we know, and we have these parts here. Now we have these parts here. Okay, this is the series. Okay, this is the series, so you can see here. Okay, and the series can be expressed also like this: 4 by 3 pi square plus 4, okay, plus 4, and here, okay, this one, it is cos n by n. What is, now we can just start substituting just for 3 values, okay, for 3 values, when n is 1, 2, 3, and so on. So when n is 1, suppose when n is 1, it will be cos x, okay, when n is 1, just I'm just substituting for these guys. Okay, let me just do this one. This will be 4, sorry, I will just do this one. So fx will be 4 by 3 pi square plus 4, this one, and goes to, and this one, okay, this one will be cos nx and n square minus 4 pi square, this guy will be sinus nx upon n, okay, upon n. So we can also write this. This is the Fourier series for this function. Okay, we can also write like this: 4 by 3 pi square plus 4 for this one, just for this one. See, for this one, what will happen? If you pick up, okay, just put here what will be, okay, yeah, just for this one, it's okay. For this one, you can just represent this one. When n is 1, okay, put here when n is 1, it will be cos x, okay, plus when n is 2, it will be cos of 2x upon, put here 2 will be 4, okay, plus when n is 3, you will get cos of 3x upon 9, okay, just in this way, minus 4 pi square. Then substitute for 3 values also. When sinus is 1, it will be sine x, plus when sine is 2, sinus 2x, okay, sinus 2, sorry, when sinus is 2, sinus of 2x upon 2, and when sinus is 3, sinus of 3x upon 3, and so on, okay, because it goes on and on, it goes on till infinite, okay, and it goes till infinite. But these three values, okay, these three values are the most important. These three values are the most important here. So you can see 1, 2, 3. This is 1, 2, 1, 2, 3. Now it's okay. Yeah. Now we are going to go for the second part of this. So this is the Fourier series for this question. The Fourier series, this one. This is the Fourier series. Okay? Fourier series. Okay? This is the Fourier series. Now, they ask us something like let me see, the second part. They say to ask what is pi squared by 12. Okay? To find pi squared by 12, that is 1 upon this guy, 1 upon 2 square minus and this on and so on and so on. It's okay? Is that true? Yes, it is what they are. Now that we have just written this one, we have just to find. They say to deduce this one, okay? To deduce something like this. Yeah, I don't know. You can see, can you see this one? Deduce that pi squared by 12 is equal to 1, 1, and so on and on and on and on and on. Okay? This is what we are going to do. But see, if you check well in this expression, just check well in this expression, you will see that this is pi by 12 and x, pi by 12, and this is 1 upon 1 square, this and 1 square, this and... You will see that this is only terms for cosine expression. Okay? If you just compare with this one, this is like 1 square, and this is 2 square, 3 square. What does it mean? It means that they substituted here a function or a number for x that made this sinus equal to 0. Okay? And to make this sinus equal to 0, it may be 0. If I put fx equal to 0, if I put x 0, 0, 0, this will be 0. Okay? But if I put here 0, 0, it will be 1 constant. Okay? It will be 1 constant here, because here we get cos of 0 is 1, cos of 0 is 1, 0, 0 is 1, cos of 0 is 1. So 0 will not be the one that will make this signal, okay? That will make this signal to alternate plus positive, plus negative, negative, plus negative, plus. The 0 will be not the expression. That's the point. 0 cannot satisfy this, okay? So let's think in a number that will make it alternate, okay, like negative, positive, negative, positive, negative, positive, in this way. Okay, so which number is this? Maybe let us try for pi, suppose, because cosinus of pi is what? Cosinus of pi is minus 1. Here will be 1 positive, okay, minus 1, and so on and on and on. Okay, yeah, this is the way you have to think. Okay, now, okay, just for f, okay, of pi, f of pi, go back. What is pi? Pi is nothing more or less than, we know f of pi, it is like where you find x you will put pi. Okay, pi square. Because this function is, what is fx? Fx is, okay, fx, what is fx? Fx is x square. Okay, so f of pi, put here pi square. Okay, f of x is this one, when x is pi. Okay, this is for x equal to pi. So we will get this one. Pi square will be equal, okay? Now see here, if I put here pi, 0, 0, and 0. Okay, this will be 0. I will remain only with this, and this. So this will be 4 pi square by 3 plus 4. Now here will be, it will be what? It will be, if it is pi, okay, pi, okay, if x is pi, okay, I will just grab this expression here to just elucidate here, to illuminate, to make you understand better. So cos of pi, so where you find x, put pi n, and this is upon n square. This part will be 0, okay, when x is pi, will be 0, and pi is 0. So now what you will do this one, here cos of n pi is equal to minus 1 to the power 1. This cos of minus pi, this is equal to this. Suppose when this n is a odd number, it will be pi, cos of pi minus 1. When n is even number, it will be what? Like 2. 2 is even number. 2 pi, it will be 1 positive. So then this expression will find this enter. Then what you will get this one, this will be 4 pi square upon 3. This is pi square, and this will be plus 4. Now here what you will get, minus, okay, this is sum of any term here, it will be minus this to the power n square, and goes to from 1 to infinite. Now from here it is very easy, just come this guy, go there, okay. Then what you will get, this one, if this guy go there, you get pi square minus 4 pi square. 3 come here, okay, just make it 3. Sorry, we'll do this one, this guy go there, okay, then you'll get this one, okay, 3 pi. Why 3 pi? Because just find the common denominator, and you will get this one by 3. It will be equal to 4 this one, okay, for this part, n is equal to 1, and here you will get minus 1 to the power n upon n square. Okay, this way it's okay. This and this, it will be minus pi square by, okay, by 3 is equal to 4. Then this series, okay, minus 1 to the power n upon n square. Is that true? So this 4 is multiplying, go there, dividing. So this will be pi square upon 12. This is minus. Then this minus, multiply all these guys, okay, all this guy by minus 1. Multiply all this guy by minus 1. What you will get, okay, you will get this one by minus 1. This guy will be positive, nice. And this, okay, this series 1, if I multiply by minus 1 times minus 1, this is minus 1 to the power n plus minus 1 to the power 1. It will be what? Minus 1 to the power n plus 1 upon n square. Okay, now pick up this expression here. Now find the terms, like find when this n is equal to 1, you will find this guy. When this term is equal to 2, you will find this, and then it is proved. Okay, I will use another paper. Okay, we got this one, pi square upon 12, it is equal to, pi square upon 12 is equal to what? Is equal to, this guy. Okay, n goes to 1, and it is minus 1 upon n plus 1, and this is n square. Now, it means that p to the power 12 put p square and this guy. So for n equal to 1, put here n equal to 1. This guy will be even, this will be equal, this will be positive. Okay, 1 square. Then for n equal to 2, this will be odd, this will be negative. And this will be 1 upon 2 square. And for n equal to 3, this will be even, this will be positive, and here it is 3 square. Okay, and so on will be negative, and so on, so on, so on. Hence, okay, hence it is proved. It is proved. Okay, okay, right side, okay, is equal to left side. Okay, that was a long way, but that was worthwhile. Okay, yeah, hence it's proof. Thank you very much. We proved, okay, that this is true. We proved, and we also found the Fourier series for this guy, that is this. Okay, yes guys, thank you very much. See you when I see you.